students, our lab 24 ECE 202L circuits and devices lab. Here already we have seen about KVL, Kirchhoff voltage law. Then we go for the Kirchhoff current law. That is 1B experiment, right? This is the concept. Here KCL, in any electrical network, the algebraic sum of current meeting at a point is 0. So what we have to verify, that is sum of the incoming current equal to sum of the outgoing current. So aim to verify the KCL. Here what are all the apparatus required? Here we see about tabular column, that is name of the equipment, type, range and for the quantity. Then for the regulated power supply, resistor, breadboard, ammeter and connecting wires. So these are all the required components. Now we move on to the circuit diagram. Here for the circuit diagram we have a RPS that is 0 to 30 volt, then R1, R2 and R3, then ammeters, 3 ammeters are connected. This is the circuit diagram. So here see the tabular column, here R1, R2, R3, then I1, I2, I3. So finally we have to calculate I2 plus I3. What is the meaning? Here see the circuit diagram, incoming current is the I1, then outgoing current is I2, then I3. So if you sum of the outgoing current, that is I2 plus I3, that is equal to incoming current. See here tabulation. Here already we got the result, I1 equal to 20 milliamp, then I2 15, then I3 5. So if you add the 2 I2 plus I3, that is finally we get 20 milliampere. What is the final result? Incoming current equal to outgoing current. See the calculation. So in the practical value, I1 equal to I2 plus I3. So 20 equal to 15 plus 5. Finally 20 equal to 20 milliamps. Now we see about the connection. Okay, so here this is the breadboard. So first of all we have a resistor value R1 270. So 270 means we have to take, that is the red, then violet. Okay, so here having red, violet and the brown. So this is the 270. We have to insert it here, any one of the place in the breadboard. Okay, see here. So here 270 is inserted. So this is the first connection I have inserted. See here 270, there is a 270 ohm I have inserted here for the 270. Next, what is the connection? This is RPS plus and minus, no? So 270 is connected to the RPS plus. Okay, this is the RPS. So this is the RPS. Here having positive and the negative. I have to take positive wire. So positive wire I have to connect it to the 270 ohm resistor. Okay, so have you understood the first one? 270, that resistor is connected to the RPS plus. So here 270 resistor, one end is connected to the RPS. Next we go for the 270 ohm resistor, another end is connected to the A1 ammeter, first ammeter, positive value. So these are all the ammeters, A1, A2, A3. Now we have to take positive ammeter A1, right? That is a A1, positive ammeter A1. Positive value is connected to the resistor. So here it will be inserted, right? Next, so then for the A1 negative, there is a ammeter negative value. You have inserted any one of the place. A1, that is the ammeter negative, right? So these are all the first connection. So here ammeter plus value is connected to the 270 resistor, one end. So 270 one end, and the negative is connected to the any one of the place. Now we have the next connection. This is the point. Okay, so one end ammeter negative end is connected to the 220, then another end connected to the 560 ohm. Now I have to take 220 ohm. 220 ohm means here red and for the brown. Okay, so 220. So 220 ohm is connected to the here. So ammeter negative value and another end of the resistor is connected to the any one of the place. Okay, right, 220 is inserted. Then so ammeter negative is connected to the 220. Then end of the 220 resistor, one of the 560 also connected. So this is the 560. 560 we have green, blue and black. So green is a 5, blue is a 6 and black is 0, totally 560 ohm. So another end of the resistor of 220 we have to connect the 560 ohm, right? So here 220 and 560 is connected. Then ammeter negative also 220 is finished. See here 220 itself we have ammeter 2 plus and minus available, no? So 220 plus we have to take the second ammeter plus value. Second ammeter plus value we have to connect it to the another end of the 220, right? So ammeter negative it will be go to the ground section. Okay, we have to place it any one of the place. We have to place it, right? Next we go for the 560. Here the 560 we have to take the A3 ammeter. It is a 0 to 10 milliampere. So I have to take positive value. 560 positive value connected to the 560 end. Negative value we have to calculate the A2, I mean ammeter 2 negative, and also see the circuit. Here A3 ammeter is connected to the A2 ground and also the RPS negative. So RPS is connected to the A3 and A2 negative of the ground. Negative value is connected to the ground section. So that's all about for the circuit connection. We recap our circuit connection. First of all we see about RPS plus value, then 270 is connected. Then for the A1 positive is connected to the end of the 270 and the negative is connected to the 220 of the one end, and the end of the 220 we have connected to the A2. Then 560 end we have a ammeter positive and the negative. Now we have to switch on the RPS, right? So first of all I have to put for the 5 volt, right? So 5 volt there is no any, so we have to change for the 10 volt also. So now we see about the KCL output. So I have to put the RPS value exactly 10. Then after that we get the result. See here for the I1 current A1 first milliampere we have a 20. Then for the second we have that nearby exactly 20. Then the third milliampere we have a 0.4. Okay, 0.4 or nearby 0.5. So this is the final output. So what is the logic we have to follow here? For the I1 current, see the circuit diagram. So I1 current 20 milliamp, then I2 and I3 20 plus 0.5. So totally if we add I2 and I3 we get the 20.5. So what is the logic for the KCL? So sum of the incoming current equal to sum of the outgoing current. So what is the incoming current here? I1 is the incoming current, then outgoing currents are I2 and I3. If we see the tabulation, so I1 current is we have a 20, then the I2 and I3 we have a 20 and 0.5. So final calculation, if we add the I2 plus I3 we get the 20.5. So nearby I1 is a 20 milliamp and I2 and I3 we have a 20.5 milliampere. Okay, if now we see about the theoretical calculation. So theoretical calculation should be matched to the approximately is matched to the practical calculation, right? See the theoretical calculation here using the current division rule, that is I2. First we have to take the outgoing currents I2 and I3, right? So the total current into opposite value of the resistor divided by total resistance. So if we have the I1 equal, so I2 is equal to I1 into, so opposite resistance 220 divided by total resistance 220 plus 560. The same logic used for the I3, right? Here I3 is available, right? I3, right? So I3 is equal to, that is the total current, that is the I1 into, so the opposite resistance value 560 divided by total resistance 560 plus 220. Then so we have to calculate the I1 now. So because of this is the incoming current, then only KCL logic will be verified. So I1 is equal to, normally I is equal to V by R. So if you put I1 equal to V1 by R1, like that we have to put, right? So this is the logic. Then if you want to so if identify the total resistance, then only we have to calculate for the I1 value, right? So the here parallel resistance are R2 and R3. We have to calculate the total resistance value. We have to reduce the resistance calculation. So parallel resistance are R2 and R3 now. So we have to apply the parallel rule. That is, what is the parallel rule? R2 into R3 divided by R1, R2 plus R3. So here we have to put for the R2, right? Here we have to put R2 plus R3. So R2 into R3, then R2 plus R3. Then we have a 220 into 560 divided by 220 plus 560. We get 157.94 the result, right? Then now we have to reduce the resistance overall structure. Okay, 10 volt is logically here available, then 270 there is no any changes. Then for the 220 and 560 are parallel, we have computed the R2 and R3 value, we get 157. Now we have to redraw the circuit. So RPS 10 volt, then 270 resistor value, then 157.94. so it is computed by the parallel resistance of the R2 and R3. Okay, so these are all the connected to the 270 and 157 is connected to the series, so we have to add it. That's a total resistance equal to 270 plus 157 equal to 427 ohm. Now we calculate the total I value or I1 value. I is equal to V by R. So I have to put the RPS value, total voltage is the 10, then computed RT value is the 427. Finally we get the 23 milliamp. Okay, so similarly if you change the total voltage should be the 5, then we get 427. That is a total resistance value 427, and we get the result 11.7. If we change 15, if we change 20 or 25, like that, if you change for the total voltage means, so depending upon that we get the I1, I2 and the I3 value. Then we do the we have to calculate I1 is identified, then we calculate the I2 and I3. How it is possible? Here see, I2 is equal to, already we designed the one formula, that is using the current division rule. So I1 value now we know, right? So we go for that. What is the if you apply for the 10 volt, I have applied for the 10 volt, isn't it? No, so practically we have assigned the 10 voltage only. So I have to move for the 10 voltage. If you apply for the 10 voltage mean we get the result 23. So I1, that is the I1 23.41 into 560. We have to apply for the first I2 formula. Then we get 16.80. so if we go for the I3 is equal to the same formula we have to choose. Here I1 into 560 divided 560 plus 20. So instead of the I1 we have to go for the 23.41. 560 divided by that value we get 16.80, right? As first I2 value is the 16.80, I3 is the we applied means we get the result 6.60. Finally I1 equal to 23.41. if we add the 16.80 and the 6.60 we get 23.40. this is the practical value. So if we apply for the RPS voltage 5 volt means we get the result 11.7 I1 value. So we have to use it instead of 23.41 we have to go for 11.40. we get 8.4 and I3 value we get the 3.3. finally if we add the I2 and I3 we get the I1. so what's the logic? Finally we follow sum of the incoming current equal to sum of the outgoing current. So I1 equal to I2 plus I3. so here in the practically we get the result. if we apply for the RPS voltage 10 volt we get the 20, that is the 20 is the I1 value. if you add the I2 plus I3 mean 20 plus 0.5, finally we get 20.5 milliamp. so this is the logic we have to follow for the KCL. Thank you students.